The last section in Unit 10 is basically going to put everything together that we've done in Unit 10. So we're going to talk about end behavior. And end behavior is the description of the values of a function as x approaches positive infinity, and the symbol for that looks like kind of like a sideways 8. Sometimes you'll see it like this. Those mean the same thing. If there's no sign, it's automatically assumed that it's positive. Or we're going to talk about negative infinity. Now the degree and the leading coefficient of a polynomial function determine its end behavior. So each polynomial graph has a distinctive shape based on its degree. So we talked about this way back in Chapter 1. I had you memorize the degree, linear. The shape of this was quadratic, this was cubic, this was quartic, and this was quintic. We actually did square root and constants, but those aren't on here right now. But anyway, when we talk about end behavior, we're interested in the arrows on the left and the right side of the graph. And when we determine that end behavior, we look at the highest degree. Now, hopefully from your exploration yesterday, you found out that if the leading coefficient is positive, the arrow, take off this S here, on the right side of the graph will point up. If the leading coefficient is negative, the arrow, again take that, on the right side of the graph will point down. Now let's just make sure everybody remembers what we're talking about when we say degree and leading coefficient. If I have 3x squared minus 2x plus 1, this is my leading coefficient if I'm in standard form. So this is my leading coefficient, and this is my degree. Now, if the degree is even, the arrows will point in the same direction. So they'll either both be up or both be down. If the degree is odd, the arrows will point in opposite directions. So either one will be up, one will be down, or one will be down and one will be up. All right, so let's see how we can put all of that together. Now, from yesterday, you looked at several different graphs. If we want to find the end behavior, so when we talk about end behavior, we're talking about the arrows on either side. All right, so really all we need to look at is the leading coefficient and the degree. So we know the leading coefficient is 2. That means it is positive. And we also know that the degree is 5, and that means it's odd. So when we talk about the lead coefficient, it's positive or negative. When we talk about the degree, it's odd or even. Now, what I want you to do is make 2 segments here. Whoops, I just broke my lid. Make 2 segments here. And we're going to start with the right arrow. Okay, starting with the right arrow, this determines if it's a positive or negative function. So if it's positive, the arrow on the right is up. And then we go back to the arrow on the left. Since it's odd, the arrows are opposite. So over here, we're just going to write odd, opposite. So O and O. So it's either going to be up and down or down and up. And since this one was positive on the right, so the right side tells if it's positive or negative. This one tells it's even or odd. Okay, once we have those arrows, then all we need to do is say the end behavior. Now, for our purposes, we're going to always say as x approaches negative infinity first. Now, what does that mean? Instead of saying arrow on the left, or arrow on the left, arrow on the right, what we're going to do is we're going to say if we're looking to the right, that's positive infinity. If we're looking up, it's positive infinity. If we're looking down, it's negative infinity. And if we're looking to the left, it's negative infinity. So we're going to describe the function. We'll pretend like we're standing right there at the center. Here, I mean, move that over there. We're standing at the center of the graph, and we are going to explain this graph to someone who can't see it. So let's put our arrows here. This one's up, this one's down. Okay, so now what we're going to say, instead of looking to the left, our arrow goes down. We're going to say, as we're on the x-axis, so this is the x-axis here, as we look to negative infinity, so as x, because these are all values of x when we go this way. So as x, and this arrow means approaches, negative infinity, then our function, which is this whole thing right here, or this arrow right here, so we only want to look at this side right here. So as x approaches negative infinity, our function is going to approach also negative infinity. So p of x approaches negative infinity. Now I'm going to switch to the other direction, and instead of saying going to the right, I'm going to say as x approaches positive infinity. My function, so now I'm saying that I'm looking this way, my function, it's pointing up, so up means positive infinity. So the function approaches positive infinity. All right, now we can do that with a function. We can also do it with a graph. So what we're going to do here, now this whole thing is on one side, so we'll just pretend like we're standing right here in the middle. And remember, this side is positive infinity, this is negative infinity, this is positive infinity, and negative infinity. So if I stand right here, we're going to decide first if our lead coefficient is positive or negative. So always look to the right side of the arrow to tell you if it's positive or negative. Since this wasn't pointing up, this is positive. If my degree odd or even, arrows are opposite, that means they're odd. Okay, now we're going to describe the end behavior. So for our purposes, and you'll see this different in textbooks sometimes, we're going to have this be the same all the time. And I do want you to write it out. Okay, so as we look to the left, or negative infinity, so as x approaches negative infinity, our function, we're looking to the left, our function is going down, or pointing, I need to put that negative there, negative infinity. So p of x, or our function, is approaching negative infinity. Okay, so now I'm standing here and I'm looking this way, which is positive infinity. So as x approaches positive infinity, when I'm looking on the right, that one is approaching positive infinity. So if these functions are odd, these should be opposite. This is odd, so these should be opposite. Okay, now the next one, we're going to look at the lead coefficient. So we want just to know if it's positive or negative. I'm looking on the right hand side, and since it's pointing down, it's negative. The arrows are pointing in the same direction, so it's going to be even. Now I'm looking for the end behavior. So again, I'm going to say as x approaches negative infinity. Okay, so as x approaches negative infinity, as I'm standing here at the center and looking along the x-axis towards negative infinity, my function is approaching negative infinity. Now I'm standing here again, and I'm looking not to the right, well actually it is to the right, but towards positive infinity. So as x approaches positive infinity, my function on the right hand side here is going down, so it's also going towards negative infinity. Even function, going in the same direction. Okay, now we're going to put everything together here. We're going to sketch a rough, and we'll just circle rough here, graph, sorry. Now, if I had you do the whole thing, I would have you factor this, but it's already factored for you here. So if we look at this, our lead coefficient is 1, so that means it's positive. The degree is 3, so that means it's odd. and now we want to put in the end behavior. So using this information, I know that the arrow on the right is positive, represents positive, so it goes up, and I know that it is odd, so this arrow has to go down. So again, when I think of positive, negative infinity, instead of saying left, left and right, up and down, I say positive and negative infinity. Okay, so first thing we're going to do, we're going to pretend we're standing right here. We're going to look to the left. So as x approaches negative infinity, so as I'm looking here, looking to the left, I look and see what this function does, and it's pointing down, so that's p of x approaches negative infinity. Now I'm going to stand back in the middle again here, and instead of saying looking to the right, I'm going to point towards positive infinity. So as x approaches positive infinity, then my function also approaches positive infinity. Okay, so how does this help us? Well, we want to get some movement here of the graph, and again, it's just a rough graph. So what we're going to do is find the x-intercept. So that means I'm going to set each one of these factors equal to 0. So I'll say x minus 6 equals 0, x plus 3 equals 0, and x minus 4 equals 0. Okay, if I add 6 to both sides, I get x equals 6, minus 3, so x equals negative 3, add 4, so x equals 4. So 6, negative 3, and 4 are my x-intercepts. All right, let's put those on the graph. Here's 6, negative 3, and 4. Okay, now it says find your y-intercept. Well, the y-intercept means that x equals 0. So when I substitute 0 in here, that goes to 0, that goes to 0, that goes to 0. So my y-coordinate equals 72. Now sometimes what will happen, that y-intercept is way off your graph, but that's okay. We'll still find it anyway because it's easy to find. So let's just put a point up here, and it's not going to be to scale, obviously, but x equals 0, and we're just going to put maybe a point way up here for 72. And again, that's not to scale. Okay, so now what we're going to do, we're going to put our arrows in here. Our right arrow was up. Our left arrow was down. And now we're just going to put some curves in here for our graph. So we're going to go through the 0, or the root, up to our 72, way up there, and then back down through our other root. And again, that's just a very rough sketch of the graph. All right, you have one on the next page to do.